Okay, welcome to macroeconomics, Introduction to Advanced Macroeconomic Analysis. It's great to see so many people here, and if you want, you can spread yourself out a little bit. There's a huge space. Maybe you like the togetherness. Maybe later on we won't have that problem because we'll all be getting sick, but until then, let's hope for the best. You don't have to wear masks. I'm not wearing one right now, but I may be in the future. Okay, so this is a course that's obligatory for master's students, and it can't be counted for credit for bachelors. So if you're a bachelor person, you're not going to get any credit for this. So you might consider your use of time. But if you are a master's student, you're in the right place. Okay, so I'm going to start with an outline of my lecture today and give you a preview for the whole course. And I hope we can make it as entertaining as possible. The first thing to do is administrative, just to get some details out of the way. And then I'll make some general remarks on the subject, because a lot of people are wondering, why am I here? Well, you're in economics. Macroeconomics is an integral part of economics, and it's a part of what we do. And it's also part of understanding the world as we observe it every day in the newspaper, or on the news, on your favorite website. I'll talk about the role of theory. This is a theoretical course, but it's also a course with lots of data. So we're trying to apply the theory in an intelligent way to help us understand the world, make sense of it. We'll start with a model. We'll start with a model that many of you may be familiar with vaguely, or maybe even intensely, and that's good. So it's like a leveling exercise. I'll propose some ideas that you'll have to get familiar with, because economics is an abstraction. Karl Marx said that. It's an abstraction. It's not reality. It's a way of thinking about reality. Okay? So all economists understand that. If you're a good economist, you understand I take the model as seriously as I can, but not more serious. Okay? And that's why I'm starting with the Solow model. It's a finger exercise. It's a way of making sure that we're on the same playing field, the same level, and then from there we'll move to a higher level. Okay? And this includes a bunch of concepts that I'll present at the very end of the lecture, concepts to remember, and those are kind of useful. It's kind of a signal, things that you really should take with you at the end of that lecture and not forget the next day. Okay? So this is a course about macro. I'll spend the whole hour talking about that, what macroeconomics is. You need to use Moodle, so make sure you know how to do that. It's presently not protected, but Leopold, the section person, the tutorial leader, tutorial postdoc who's running the show, will present that information to you. He'll give you the password to get on the Moodle page, and it will be distributed then, and then in 2 weeks we'll close it, so it'll be impossible to get on the page. All the important announcements, communication, if you have to talk to your friends, have some question, you want to form a study group, very useful activity. You can do it at that time. There's a final exam, and that's the whole thing. There's no partial credit for anything else. Okay, so it puts a lot of pressure on you. That's why it's useful to go to the weekly tutorials, and it's also good to come to lecture. It's actually best to watch a movie first. Watch the video of this course in 2018, get a feeling for what's going to be talked about, and then you see me and you can ask questions. That's the format that I'm going to be trying to do. It's called flipped classroom. So I come from the United States. We like to have open discussion, Socratic method. I don't mind being challenged. I welcome it, as long as it's not just being aggressive. You know, if you have something to say, that's great. If you don't understand something, just ask a question. But that means I'd hope that you had looked at the video beforehand. It's an hour-and-a-half investment on YouTube, and I'm not earning any money on it. But it's doing pretty well. The first lecture got 100,000 hits. That's almost rock star status. But after that, it goes down very quickly. I wonder why. You know, the point of this is there are two meetings. There's a meeting here on Tuesdays, and there's this we call a tutorial session, or I call it repetition or section. Means basically in a small group, you have a chance to work through the problem exercises and understand why the model actually can be applied, the models that we learn, how they're useful. You can discuss with Leopold. He's a young and dynamic Austrian rising star in the field, so he's really got a lot of input, and you'll really enjoy interacting with him. There's a really interesting book that I just discovered a few weeks ago that I put on the internet. It's a free book. It will be eventually published as a real book, but the guys just want to put it out there. I like it more than anything I've seen recently, and it's based on people that I've personally taken courses from when I was a graduate student, so I really like this. So I would urge you to download it and follow the readings. Most of the readings will refer to one chapter or one part of a chapter in that ebook. I mean, it's just a PDF file. And it's by Comparative Sturzenegger, who's actually Argentinian, but he has a German name or Austrian name, and Andres Velasco. And it's an LSE book. And like I said, it's free and it's fairly short. I mean, the chapters are short. You could blow these things up into books. Each chapter is a potential book, but we don't do that. I'd just like you to do those readings. And there's some other stuff like handouts and articles that come from the literature that you might be interested in, some suggested reading as well. Okay, so macro is about explaining two things. One is growth in our welfare and well-being, growth. Okay, and the other is fluctuations, movements around the trend. So that's really easy for us to understand. You say, well, how do you separate those? Okay, if you look at Italy, you might wonder, hey, they're in a bad way. It looks like a real permanent downturn. Okay, so this is a challenge for us, but in general, we make this separation because it's a good starting point. And I'll show you why in a second. The data are unequivocal. In the past 200 years, we've had economic growth in almost all countries, I would say in all countries, but at different rates. And those rates accumulate because of compounding. So eventually we run into situations where the levels are so far apart from each other, either in terms of total GDP or GDP per capita, that we really have to start worrying, what are these countries doing wrong or right? And that's why we have the first part of this course focusing on growth theory. Okay? So I could throw out some interesting facts. Did anybody know that Egypt was richer than Turkey 50 years ago? Per capita GDP, much richer. And now, flipped. Turkey is the rising star of the developing world. There's no question about it. Why? Despite all the things you might hear about the regime there, it's actually growing. It's been growing a lot since 1960. Okay, so that's an interesting fact. That's a fact we have to discuss, understand, maybe use economic theory to get our hands on it. There are countries in Africa that are growing very fast. There are countries in Africa that grew not at all for 20, 30 years. Civil war, ethnic strife, and then suddenly they got their act together and started growing. Is that part of the story? Okay, but there are many parts of the story. We're going to talk about fluctuations. That's something that we deal with in the advanced world. Advanced economies have to deal with fluctuations. Right now, we're facing a very severe potential recession. Okay, but we've had recessions before. We had the COVID recession. We had the great financial crisis. China is facing a crisis right now in the financial world, spilling over to the real world. Why is that? Yeah? What's the connection? What's the connection between the financial world and the real economy? Okay, so understanding that is what we're also about. Okay? Now, if you did an undergraduate course, if you did any sort of undergraduate work in economics, you might remember something called an ASAD model, pushing curves around. So I'll probably make recourse to that at some point. I'll probably grab that as a last resort, because we can all understand this. This is Marshall, right? Supply and demand, right? It's really an easy way to understand. ASAD is a little bit different because it's inflation on the vertical axis and GDP gap on the horizontal axis, but it's still a pretty good way to understand the world. So at the end of this course, you'll understand why that's still a good way to start. ASAD. Okay? We're going to talk about expectations. This is really important. We know that expectations of the future determine the present. Stock market incorporates expectations of the future. Right? If you want to see how the markets are looking at the current situation, look at the price of goods that are traded in spot markets that are assets, financial assets. The price of UK sterling gilt treasury bonds, right? What's the interest rate that's implied by that? We'll have two models that we'll play with. One is one that is basically a very rarefied implementation of the simplest stuff you learn in microeconomics. Okay, it's called the real business cycle, so it's asking a really funny question. Is the financial sector so necessary to understand these fluctuations and the trend? All right, and then there's this answer which is, it's not enough. We need to understand the financial sector. We need to understand why the central bank is so important. Every country has a central bank. Some countries have the same central bank and not even part of the... Some people use other countries' currencies. There are all sorts of interesting, weird variants on this. So that's part of what makes it a lot of fun. And John Maynard Keynes gave us this notion that maybe prices don't adjust fast enough to make monetary matters irrelevant. So because of that, the central bank does have an effect. And we do care about what the European Central Bank does, what the Fed does, what the Bank of Mexico, the Bank of Russia. They all have some effect on the economy in real terms, even though we might think that in the long run, money doesn't matter. Okay, so economics is like a juggling act of all these different ideas, making them consistent with the reality that we observe every day. And that's what I'd like you to take from this course. Get inspired, this is really cool stuff. I can look in the newspaper, man. I mean, Germany has 8% inflation this year. Holy cow. That hasn't happened since 1974. Back then, the price of oil went up by 300%, right? Maybe we could learn something from those two facts. And that's what we're going to do. Okay, so that's the overview of the course. Let me start with talking about what macroeconomics is about. It's about the aggregate. It's like a bird flying over the surface of the earth and making a survey. So we really can't talk about individuals. We're not talking about households or firms. We're talking about the aggregate. And the aggregate is important because it takes us all along. We're part of this big average, right? The said inflation rate is the average of millions of prices moving. The the common movement of those million prices in Germany is the German inflation rate, not the level. And you're smart economists, you understand the difference between a level and a rate of growth. GDP is an average output of the entire economy. If you divide by people, or you take the sum, it's the total aggregate activity over some period. Right? So it's another measurement that is certainly flawed. And if you took micro or macro in undergraduate, you know that these things are all subject to measurement. So the closer you observe somebody, there's always a risk they may change their behavior. They don't report it anymore. So there's this tension between observability and reality. It's like the Heisenberg principle in physics. It's more than just adding up markets. And we think of microeconomics as the foundation. So I'll talk a lot about foundations of macro. I mean the micro. So I love my microeconomic colleagues. They don't love me because we're really loose and dirty and kind of imprecise. That's because the object we're interested in is imprecise. Because GDP is not exact. Even after 5 years, the measurement is still not exact. You know why. I'm not even going to bother to tell you, but maybe you want to talk about it later. But we need to know those micro foundations, so I'll come back all the time to these micro principles. What's going on in the background? Labor supply. Do people really want to work? Are they really working? Are firms maximizing profits? Are firms setting prices? Is it really a competitive market? Even more crucially, how do people behave when they buy stuff? Do they have rational behavior, or is it like they're just completely nuts? So these are kind of the things. And if you have a lot of people who are nuts, on average, they still might be rational, right? So think about it. The tyranny of the averages it benefits us because then we can sort of make an appeal to the average behavior of the representative agent. Okay? So GDP, everybody knows what that is. Gross domestic product. At current prices or at constant prices. Why constant prices? Why would we prefer to use constant prices? Well, we have this notion, yeah? Yeah, because we have this notion that if all prices go up, and that makes us look wealthier, that's probably not a good indication that we are actually wealthier, because the money that we're using is the numeraire to pay for that GDP, and that just means that the GDP is worth the money is worth less in terms of the GDP, which what we care about. We care about the goods and services that we can consume and spend on our health. It's not just about consumption. Or invest in our future, invest in saving the environment. That's all going into GDP. Expenditures on environmental abatement, improvement goes into GDP too. So final sales, that's the official expenditure notion of GDP. It's also income to factors of production. It's also total value added. 3 ways of looking at it. We just talked about inflation. It's the rate of change in this measure, this general average of prices across the economy. There are many ways to do that. Okay, I'm not going to go into that because that's undergraduate stuff, but you should go back and look at a textbook if you're not quite sure about it. There are many different ways to construct an average, but you want to weight the goods that are important, like oil and gas. So when those prices go up a little bit, that makes a big difference in the price index. It makes a big difference numerically in the inflation rate. Okay, so keep that in mind. I mean, why is the gas price in Europe so important for European inflation? Because it's a big part of what we do and eat and consume or use as inputs to make other goods that we eat and consume and use and invest. Okay? We care about the finance world, even though we may not like it. It's there, and if we want to borrow money, we're going to have to pay an interest rate, and the interest rate is rising now. It's rising everywhere. And this is causing a lot of discomfort. Many of you may want to become an entrepreneur and try to raise money in the capital markets. So you have to get other people who have money to invest in your thing, in your project. And if you're just saving for your retirement, you might be caring about that as well. Or if you have a retirement plan. You shouldn't be thinking about retirement, but at some point you will think about retirement. So it's important. And of course, many of you may be thinking about what are you going to do after you finish this program. And I know you're all going to have a great job. The job market is really good right now. If you quit now, you'll probably get a job with probability 1. But you want to finish your degree. Maybe some of you are working on the side. Well, this may not be the same thing. It may not be the same case in 5 years. And it certainly wasn't when I came to Germany in the 1990s. Unemployment in East Germany was very high, in East Berlin. Okay, so it's not something that you can just kind of ride on, because it's an average tendency of the average difficulty to find a job. We won't talk too much about this, but if you want to learn more about it, take my other courses in labor economics. We'll talk about it in more detail. But it's certainly a part of the business cycle. Unemployment goes down when output goes up relative to trend. We won't talk too much about this one, but my postdoc Leopold does the exchange rate, right? What determines the exchange rate? The nominal exchange rate, and what determines the real exchange rate? The purchasing power of the euro in terms of US goods, right? That's a somewhat different concept. Or what determines the Turkish lira exchange rate? If those of you are interested in that stuff, this is an extremely exciting variable. You know, it's had an incredible history, and it has an incredible effect on the Turkish economy, right? And what determines it? Is it the free market? Well, we hope so. Are there financial elements of that determination that are outside of the control of the Turkish central bank? Yes. Hi. Because Turkey is an open economy and they trade freely in assets with the rest of the world. So that's part of the story. So we'll start with economic growth today. It's kind of like a finger exercise. So I'll start by entertaining you a little bit. I want to talk about one of my favorite economists, even though she was a bit crazy, Joan Robinson. So who was Joan Robinson? There she is. In her later years, she was a somewhat different-looking Cambridge student back in the 1930s. Or actually, she was already a professor, or she was a lecturer. Who was this lady? An economist. Okay, first and foremost, being an economist in the 1920s and 1930s and being a woman was very, very difficult. And being in England at the same time, very, very, very difficult. Okay? Back then, things were much more sexist than they are today. So she had a tough go. But she was smart and she had good ideas. And we learn in economics, in many courses in this university, that human capital is the biggest resource. And the biggest waste of the past years has been to discriminate against groups and genders and keeping those people out of the flow of ideas and talent, right? There's studies in the United States that show 15% loss of GDP because of discrimination. You know? So getting rid of discrimination means good people rise to the top. Good evening. Good day. Okay. She was the mother of the theory of monopolistic competition. Many of you may know what that is. If you don't, you'll learn about it. It's the idea that firms don't behave in a perfectly competitive market. They actually have some market power. They're not complete monopolists. She cooked that up herself with another guy named Arthur Chamberlain separately. But a lot of people give her credit because she extended this to look at labor markets and how firms can push wages down. Okay? So firms don't just take the wage, like I'm going to tell you later. They actually exert a mild influence, especially if they're a big employer like Walmart. Okay? That's really interesting. She thought of that in the 1930s, and people kind of poo-pooed her for a while, and she never got the Nobel Prize. She was a staunch critic of what we do today. So keep that in mind. You know, being a good economist means to be critical, and she was, and then understand the critic, not just sort of just spew it out like a lot of people do mechanically on talk shows and stuff. I don't like that, okay? And she didn't get the Nobel Prize, and that's considered, in retrospect, given her contribution, kind of a sad thing. She died in 1983. She said, the reason we study economics, the reason you study economics, because most of you probably won't become a professor somewhere, is to avoid being fooled by economists. And that's a deep thought. Understanding what we do and being critical enough, as she did, to deal with it. Now, she was, in her later years, was a bit on the crazy side. I have to say, she visited North Korea and praised its wonderful command economy style. This was back in the 1950s and 60s. She got that wrong. And she also praised other aspects of centrally planned economies, but doesn't detract, in my view, from her ultimate contribution as a person in the field. Okay, so keep that in mind. It's a great bonus question for the final exam. What did Joan Robinson say? So that's the last time I'm going to say it. Well, I may actually mention it later on. Okay? So what is the objective of today's lecture? We're going to try to understand the facts. So that's kind of a no-brainer. It's like a doctor wants to understand what it means to have a fever or to have cancer. That's the easy one. Being able to write down the facts. What is GDP in Germany today? Does anybody have an idea? It's a big number.
We call it 5 billion?
That's pretty close. Nominal or real? Yeah, good. Okay, so first off, it's 1,000 billion. We call that a trillion in American English. The British called that a billion. I don't think we're going to do the British thing. So a trillion, 10 to the 12th power. Those are the kind of numbers we deal with, 10 to the 12th power. The United States GDP is over 20 trillion US dollars. That's because the US is a bigger country. It's got more people. Even if the US guys were as productive as the Germans, you'd expect US GDP to be bigger. China, if China gets to be the same economic power per capita that Germany is, it will certainly be the largest economy in the world. Okay, so it's a scaling device. These are things we're going to learn automatically as we cruise through the course. But more importantly is to understand these facts. How do we connect the facts? Why is China growing so fast? Why is Germany so wealthy? Why is Angola so poor? Right? These are the questions we have to ask. And that's what turns me on. That's why Robert Lucas said, once you start thinking about growth and growth theory, it's hard to think about anything else. Because I'm going to show you a picture in a second that will just blow your mind, right? It's the fact that economies have grown. But let's go back to what it means to understand the facts. It means to have a theory. And a theory is a way of linking causes to consequences. So this is the best definition of a theory I've seen recently in the past 30 years that I've been doing this stuff. How do you translate a cause into a consequence? And to do that cleanly. If the Fed of the United States raises interest rates by 100 basis points, what happens? Okay? Or if the European Central Bank does the same thing, what happens? If the the finance minister decides to raise taxes on diesel. That's a very important fuel. That's going to have an effect on the macroeconomy. What happens? All right? I'm not going to ask why he did that or why she did that. I'm going to ask what happens if. So it's a causal relationship. So to do this, we need to use mathematics. This is the way to speak to each other. It's a language. Right? So I don't tell my undergraduates this, try to lure them into the field. But once you become masters, I stick it to you. You know, you have to deal with this. And if you buy the first idea, causation, then mathematics is a very easy way to communicate that causation. Okay? So we talk about exogenous variables that are given in our minds, and then the endogenous outcome that results from changing those exogenous variables. Right? That's an easy way. That's one of our contributions. Physics doesn't have that problem. Right? Physics, everything is pretty clear, I think. Maybe not so when you get really small. But in general, it's much clearer than we are. Okay? So this is Robert King, famous macro guy, editor of the IAMA for many, many years, Rochester. Here's another one. This is an older quotation. It's a method rather than a doctrine. So it's not religion. It shouldn't be religion. You shouldn't automatically just spew out the free market doctrine. It's a way of organizing your thoughts. Now that's a really cool statement. So who said that? Good. Did you read it? Okay, good. Very good. That's a good reason to watch the lecture. So Keynes said this before he became a Keynesian. He said this when he he was an editor of a volume of contributions to economic theory. Okay, so fantastic summary of what we do, and it kind of helps us understand why we need models, because models are ways to organize our thoughts. It's a way of abstracting. So I talked about Karl Marx. He said that. He talked about the chemist with his different beakers and test tubes, and you conduct experiments, and you want to conclude that this would work in the big scale. That's exactly what we do. Okay, we're doing the same thing. It's a way of organizing our thoughts. It's a compact way of presenting a theory. So a theory is this general notion: money causes inflation in the long run. That's a statement. Do I have a good theory? Yeah, that's a pretty good theory. We can test it. We can reject it. Is there a mathematical way of presenting it? Yeah, there are many really easy, stupid mathematical ways to present it. And there are smarter ways that are a bit more sophisticated. And that's kind of what you're going to learn how to judge, right? And we've gone a long way. I mean, Hume, the famous economist David Hume, he wasn't an economist, he was a philosopher, but he also got into economics for like 5 minutes and wrote this treatise that we still use today. And he said that basically money and prices, it's kind of a veil, right? So back then, he said that in 1756, and we're still kind of puzzling, how do we get to that long run, right? That's the magic of what we're going to do. I told you about the abstraction, and there are many metaphors. So my colleagues will often use these metaphors in classes like this one. Okay, so it's a lens. It's a way of looking at reality. When you use a lens, sometimes the lens is tinted, so it filters out light that you don't want to look at. Maybe it sharpens the image a little bit because your eyes are no good. Maybe it does something else. Maybe it filters complete parts of the spectrum out. It's also a map. It tells you where to look. Where do I look? And if you're looking for a treasure, a map is helpful. The treasure may not be there. So maybe it's the wrong map. Maybe the model's not appropriate. But it helps. It helps to focus ideas. And finally, it's a window. Again, you're looking at reality, which is much more complicated. And we're looking at, and we can't go through the window. We can't actually get out there. Ed Prescott, the famous economist from Minnesota and later Arizona, said that a model is a laboratory. So he goes even further and says we can do experiments in this laboratory because in economics we cannot experiment with you and you and you. We can't do that. It's unethical. I can't just go to Argentina and cause a hyperinflation. I would like to. It would probably get me a Nobel Prize if I could do that, but I can't. So we stick to models. That's our Reagentienglas. as Marx said, okay? So what makes a good model? It has to be falsifiable. It has to have content that we can prove that it's wrong if it doesn't work. Okay, so that's really a super, super insightful idea. It's useful in life. Falsification. That's a great, because if you can't falsify a theory, it's like religion then. And religion is something you might appreciate and even treasure, but it's not what we do. Trying not to do that, because we want to understand the world independent of the assumptions that you might associate with that. We want to make sure that predictions are validated. So we want to predict, not just falsify. Maybe we want to make predictions about new situations like the one we're facing right now. The one we're facing right now is very new. We haven't seen gas prices, which are near and dear to this country. Germany has an incredible dependence on natural gas. Maybe it's their fault. Maybe it's like a Faustian bargain the Germans and the Russians went into 30 years ago, but it's payback time now because it's threatening the standards of living of this country. The price of gas going up by 500% is outside the realm of observation. We've never seen this before. We have not seen this before. So let's deal with it. Economics can help us predict an increase in inflation, for one, a loss in standard of living, for two, possible demands for redistribution, for three. All these things are predicted by good economic theory. It has to be logically consistent. We demand that of anything. Does it make sense, right? Or is it just hocus pocus? There is hocus pocus in the economic world. It should be simple. Simple as possible. Einstein said it should be as simple as possible, but not simpler. Okay, so I think it's pretty wise. We want to go as far as we can, but if we oversimplify and lose the thread, then it's no use. Sorry about that. I think my battery just ran out. It always happens. Okay. Milton Friedman, you've heard of him. He said models don't have to be realistic. So this is controversial. But his idea has kind of forced its way into our thought. He basically said if a model can predict and explain and organize our thoughts, then it doesn't have to be totally realistic. So if we use a representative agent, if we pretend like the economy's consumption behavior is proxied for by a representative household, then it's pretty good starting point. Okay? So Friedman pushed this view very hard in the 1950s and 60s. And also the idea of whether theory has to be based on rational people. Okay? Because again, you want to be simple, realistic. People are sometimes irrational, and maybe having more than one person is better than having just one person. So these are things that we're still fighting about, right? But again, it's an open question. The realism criterion is disputed quite a bit, but in the end, we're kind of in Friedman's corner, okay? Because Friedman said if you watch a pool player, you know how you play pool, billiards, and you hit one ball and it hits another ball and knocks it into the pocket. It looks like the guy is solving some complex physics problem. In fact, if you could write down that problem with physics, you could probably predict his behavior. But do you need that? Well, maybe, if it works. Maybe he's got a good eye and he has an idea of how the angle and everything works, but maybe the right way of explaining his behavior is to write down this mathematical model that involves physics. Okay, so Friedman said this might be the way to go. Again, this is something discourse and publications and econometric evidence would verify or falsify. Somebody had a question. Yeah.
I was just wondering if we equate realistic with applicable, so do we need to be able to apply it?
Oh yeah, you want to apply it. But the question is the underlying stuff, does it have to be, I mean, we know the world doesn't consist of a single representative agent, right? We know that. It probably doesn't even look like it's represented by 10 representative agents. But maybe and this is a current subject of discussion, maybe a model with 10 different classes of agents with different levels of wealth might actually do a better job than the single representative agent, because we know there are distributional effects. So wealthy people might behave differently in terms of the way they respond to certain stimuli than less wealthy people. Okay, so again, it all depends on the data. The ultimate question is how does it test against the data? And if we're honest, we'll say, okay, that theory is no good. We'll throw it away. Anybody else on that? Okay, so we can't use lab. We can't use, some microeconomists use the laboratory, but these are rarefied sort of experiments that aren't so, at least to my mind, so easy to map into what we do today. So it's hard to generate a hyperinflation in a laboratory because our economic relations are so complicated. All the things you're going to do today that have to do with the economy, or even though you're at university right now, are still enormous. And when you go out and start working and start interacting, it's going to be even more so. So it's our laboratory. There are two ways to do this. One is deductive. So you start at the bottom with some assumptions, and then you start doing the logical implications of these two assumptions, using this idea or this implication, and then sort of building up a structure from below. And that's what macroeconomic theory does quite well. But we don't challenge the underlying assumptions, like whether people are rational or not. Is rational choice. If I prefer A to B and B to C, doesn't it mean that I prefer A to C? And if people don't obey that, maybe I should start from scratch. Okay, so there's certain things we don't challenge. People's rationality, for example, will be very central to what we're doing. But you can also go the other way around. You can go from top down. So you can actually just observe the world, look at how people interact, and then say, hey, we need a different theory. We need a theory that just kind of accounts for this behavior. So there are lots of people working in economics today that actually try to use experiments to predict how people react, and then use that as a basis for a theory. Okay? And there's some really fantastic examples of that. I'd love to go into them. I'll tell you one. One is called the ultimatum game. Does anyone know the ultimatum game? Okay, so we play this game. I have 100 euros, and you're playing this game with me, and I give you a part of that 100 euros, and you can reject it or accept it. Okay? So what would be the rational thing for me to do would be to give you 1 cent. And then say, take it, or, and you should say, take it. Yeah, of course I'll take it. I'll take a cent, right? Well, it turns out empirically, 40% of the majority of the offers that are encountered in this game are 40%, because it turns out that if you offer 1 cent, the other person will spite you. You say, the cent doesn't interest me. I think you're just being so ridiculously greedy. I'm gonna hurt you. I'm gonna veto the game. Okay, so the average successful offer is 40%. And this kind of reminds me of trade union negotiations with management, right? There's something like that going on. So this is an example of where inductive theory actually may get the better hand in this particular example. It has little to do with macroeconomics, but it might tell you something about what we need to think about. So Robert Lucas said this. He said, bottom up would be like writing a computer program. And the computer program's equations is basically summarizing the economy's behavior, and you're summing this up to get a macroeconomic picture. Okay, so he was a Nobel Prize laureate. He must have known what he was talking about. There's also this other view, which kind of goes back to Kepler, who learned about the non-circularity of planetary orbits by just staring at planets for many, many, many years. I imagine going every night to the observatory and writing down where the planets are and saying, hey, the circular orbit doesn't work. Right? So this kind of reminds me of the ultimatum game. And this is Christopher Sims, an econometrician. So actually a very destructive statement for his field, but it also got him a Nobel Prize. So let's start to talk about the Solow growth model. We'll talk about a real model, give you some ideas. We'll talk about the growth phenomenon, because that's really what it's all about. If you don't remember this, or if you've never seen it before, then check out a textbook. I've got an undergraduate textbook that you might want to look at. It's, there's a new edition, actually just came out, chapter 3. A more mathematical version would be Campante et al., which is on the reading list, and it's also electronically available. These slides will be made available after the lecture, immediately, unless I find a mistake. So I won't give them to you before, because then you won't come. And if you really like these videos, then you can get a preview of these slides, but it won't be exactly the same, because I'm always revising them right before the last. This is a prelude to the Solow, a warm-up exercise for the overlapping generations model that we'll talk about next week. So the Solow model is kind of it's finger exercise. It's a way of learning how to play the piano the slow way, basically. But I'm going to use this as a way of showing you that it combines inductive and deductive approaches. I'll mention that as we go through the model. Right? There's some things we assume from the bottom, and there's some things that we just observe from the top and impose. So let's start by talking about Lucas. Robert Lucas said, once you start thinking about growth, you can't stop thinking about it, which reminds me a little bit of my own experience. It's really true. If you're concerned about human welfare, GDP per capita is a very important determinant of that welfare. Like it or not, you can be happier, you can be healthier without GDP per capita, but it certainly helps. Okay, and I just came back from Cuba. Cuba is a really, really happy country, but it's also a very poor country, right? So getting economic growth up, thinking about environmental consequences, which I will. I'm going to talk about that next time. And Leopold will talk about it in the problem set. We need to think about that too, but that's part of it. If you want to solve the CO2 problem, we got to figure out ways to do it. We got to use resources to do that. And where do you get the resources from? They don't fall from heaven, right? So welcome, just have a seat. So Robert Lucas said that in '88. So this is a plot of economic historians' view of economic history since the mid-19th century. It looks like a hockey stick. It's really exploding. And there are certain phases when it goes down. Those are associated with wars, conflicts, political conflicts, military conflicts. Otherwise, things are going up. The last dip is the pandemic. So this is really up to date. Now this is the level of GDP, constant prices of 2000. And you can imagine, how in the world do we get this? Well, there are economic historians that spend their whole lives looking for these numbers to reconstruct data from the 19th century on Dutch GDP. I'm thinking of Angus Madison, or Germany, or the United Kingdom, or France. So we're really sitting on their shoulders, and they're giving this fantastic data. You can see that there's no question about it. We're much better off than our grandmother's grandmother. There's no question about it, if you're in one of these countries. And this has been adjusted. This is not per capita. This is the population of Germany and France and England have not exploded. I'll show you the data in a second. So this is really an indication of the size of the economy. Now, we see doubling happening very frequently. So this is exponential growth. How would I make sense of that? What will be the next step? Well, this would be a reflex action for you. You take the natural logarithm, right? We're going to show how this is the step, the Napierian natural logarithm. That is a function that transforms x into something. And that something, if the something is growing at an exponential rate, the logarithmic transformation flattens it out. It makes it into a linear function. Okay, so that's going to help us understand that picture. Let me just remind you what the logarithmic function is. So you really want to study this if you haven't done it before. It's a function. It's monotone. There's a base 10 logarithm. We're not going to talk about it. This is the base E logarithm. Euler's constant, 2.71 something. Okay? Don't look that up. The magic of that is it's kind of this transformation is we're going to use in macroeconomics because changes in the natural logarithm are like growth rates. So once you figure that out, you can take the price data from Germany, the price index, CPI, Verbraucherpreisindex, or you can take the price of oil or the price of eggs, and you can take the logarithm of that, and the changes in the logarithm from one period to the next is a growth rate over that period, approximately, okay? So this is like, I mean, a lot of people, this is, aha, wow. And other people have seen it in high school. Doesn't matter. You're going to see it now. It flattens out exponential growing trends, and if the trend is constant, we get a flat. Okay, so that's a great way to get a visual, because a lot of us need visuals to understand stuff, and that's what I'm going to give to you right now. So mathematically, you can show that if the function is an exponential function, with t being time, right? T is time, so as t grows, the thing grows. As t increases linear, the exponential function rises exponentially. And t is calendar time. This is a continuous version. Okay, so if you take the log, look what happens. We get g, the growth rate, times t. It's linear. Wow. That's really cool. That works for continuous functions. It also works for discretely changing objects. And remember, exponential growth is really, really tricky. If something is growing at 5% per year, let's take China. China was growing at 10% per year in real terms for almost more than 20 years. How long does it take for something to double if it's growing at 10% per year? Yeah.
7 years.
Yeah, 7. Wow. How does that happen? It's compound growth. Because 7% is big, and if you add 7% to what you started with and you make that grow by 7%, it's growing fast. So that's the rule of 70. Take 70 divided by the growth rate, and that's approximately the doubling time of your process. Okay? I teach that to my bachelors. That's also will impress anybody at a McKinsey meeting. If you go work for McKinsey and tell them that, maybe some of them knew it, but they forgot it. Exponential growth is kick butt growth. And even things that are growing like 1% per year, it will double in 70 years. Right? So small differences may be growing. The difference between the United States and Mexico may be growing over time. And this means that the levels are going to be quite far from each other in very little time, depending on the rate of growth. Okay? So keep that in mind. And for small changes and for small rates of growth, you can use the following approximation. Okay, so the log of 1 plus a little thing is approximately equal to the little thing. And using that, you can see how if you take logs of my gas price and then take first differences, that's kind of like the growth rate, suitably normalized for the time period. So if it's annual data, that'd be an annual growth rate. Hello, good to see you. You can sit there, yeah, that's good. So this is the notation we'll be using throughout the course. The delta stands for change. So delta x t is equal to xt minus 1. T is the index of time. Okay? It's a really simple notation. It's going to accompany us the entire year, or at least this semester. All right. So here's my data again. I'm going to take logs of this picture. What's going to happen? It's going to look pretty flat. It looks really flat, except for these really large deviations which we associate with world wars and financial crises. Okay, so economic growth seems to be part of the story. Now look at this last little dip there. If I actually updated this to the current quarter in Germany, it's recovered its trend. But not every country has. So Italy is actually below its trend. Many countries in Southern Europe are below their trend. But in general, if you fitted a line, you would get a number like 2% per year. 2 to 2.1%. And I'll show you some data later in this lecture. So we call that long-run economic growth. It seems to be growing, okay? And for our lifetimes, it will probably continue to grow. Although we know there are consequences of that growth that are really bothering me and you probably also, which is CO2, the climate crisis, global warming, because this growth is associated with a similar hockey stick of CO2 emissions. Okay? But I predict that economic growth can handle that because you're going to have to learn how to use resources to control that. Okay, either extract it from the exhaust of the cars and the industrial activity, the electrical generation, or just switch to more carbon avoiding technologies. Okay, you still need to get those resources into the application. So we need growth to feed that abatement, to feed that reduction of CO2 in the atmosphere. Okay, so we'll talk about that in a problem set later in a different context. So let's talk about the Solow model now in detail. Again, here's the US, take logs. You can see that there's definitely a declining trend. So if you're interested in this, every country, and the US is the leading example, every country is suffering from a slowdown in the underlying rate of growth since the 1970s. Okay, and China has had a great run, but underlying growth in China is also suffering from this slowdown in technical, we call it technical progress. So understanding that is why we need the Solow model. Let me just remind you that we talk about two different ways of measuring data. We talk about continuous and discrete time measurements. So this is just a footnote for you in case you're interested. The continuous time would assume that at any point in time I can give you the value of some function. We also have discrete measurements. So we measure GDP one time every 3 months at best. The CPI, the Consumer Price Index, is measured every month. Some variables are measured every day. You know, the weather is measured almost continuously. There's also other stuff that we do on a continuous basis. We can look at stock prices second by second, millisecond by millisecond. So in a sense, the continuous time framework is an abstraction. If we could measure it, what would it do? So a lot of times I'll use the continuous time framework, but in macro, we tend not to. We tend to use a discrete setup because we unfortunately only have quarterly data. We have only monthly data. So we have to make do until the next measurement comes. Now, there's real-time measurement. You know, has anyone heard of the Atlanta Fed, the Atlanta Federal Reserve Bank? If you go on their website, you can get a guess of GDP that they get in real time by sampling stuff today. You know, it's pretty amazing, but it's not GDP. It's just an estimate. Okay, so that would be a continuous time measurement. You can check those guys, and they're changing the measurement all the time. Atlanta Fed GDP estimate. Okay, but in discrete time, we would use something like this. So we would think of if something is growing exponentially, we can approximate it with a discrete time rate of growth, gamma, a constant, raised to the power t. 1 plus that raised to the power t. That thing also grows in a jagged way exponentially, right? If you take logs of that, you see what I'm talking about. Take logs of that, you get exactly the same result as before, approximately. Okay, the slides will be made available later. That's why we talk about first differences. If you want to construct an approximate rate of growth, the cheap and dirty way to do that is just to take logarithms of the original data and then take first differences. So I think we'll do that in one of the problem sets, give a chance to compute an inflation rate. Okay, so here's growth. Here's the growth phenomenon that I talked about before. This is the, you can see that the measurements point to the same thing that the picture pointed to in many, many different countries. These are all developed countries, which is kind of unfair because we know a lot of countries have not reached the level of development that we have here in this country or in other Western countries. The growth rates translate into differences of real GDP that are quite different. So again, take a look at Bangladesh. Modest rate of growth, not so much lower, but the base was low to start with, and they haven't caught up. Right? Argentina was one of the richest countries in the world in 1900. I think it was number 6. Why would Argentina be rich in 1906 or 1900? What? Yeah, you have great land. You have cows coming out of your ears. You exported cows more than the United States did back in the day. And whatever happened after that, we can talk about it, but it wasn't great because they haven't kept up with the Bundesliga, right? So these are things that economic growth gets us excited about. We're talking about GDP. We're talking about value added at market prices. We're talking about final sales. We could talk about value added. We could also talk about income of factors of production. That's what we're going to be tracking in the Solow model. The Solow model is about understanding GDP as value added. So we're going to ask the question, where does that come from? What creates value added? Again, you can measure it in different ways, and that's the great thing about macro. There are 3 ways to skin this cat. All right, you have final sales, you have income of factors of production, and you have value added. Value added meaning each component of the value added chain is added together starting from the cost of inputs at the beginning. They all should come up with the same number. Okay? So this is good for us, and this is going to help us drive the model. I talked already about the idea of having a real concept. So in the Solow model, we'll talk about real GDP. We'll not talk about nominal GDP. We're not talking about euros of today. So we're going to try to factor out inflation. We're going to ignore inflation for our discussion today. Okay, so the notion is that somehow the price of GDP in terms of euros today doesn't really matter for the underlying concept, for the underlying development. Now that's kind of an assumption. But, Solow proposed this, and before that, people were thinking the same way. We're still thinking the same way. I'm going to present some evidence later that no matter what the money supply and prices do, GDP has its own sort of track. Okay, so you can affect it in the short run, but if we use the Solow to predict the long run, we're okay. Right? Yeah. That's how we measure it. Okay, but I'm trying to be a bit dramatic. The reason why we don't want to use current prices because we don't want to conflate inflation with progress. Because GDP is big already, and if you compare it with 10 years ago, in Germany, it's much bigger in nominal terms than it would convey if it were really measuring a real concept. So we have to control for prices. Right. Okay, so again, I'm kind of beating a dead cat now, but it's important to remind you, I'm not an ideologue on this, but I do think that GDP is important. And here's some good evidence. Countries that did the transformation, people in those countries got happier. And the best example are East Germans. East Germans were unhappy before the transformation, and we observe that GDP per capita in East Germany has risen by maybe 250%. And people seem to be happier. It's true in Poland. There's been some setbacks. True in Russia and Ukraine. This is ending in 2014, so no bets on what's happened since then. This is a plot of countries around the world and the life satisfaction index. So this looks to me like a convex hull of possibilities. You can be happier if you're poor, but if you're rich, you're unlikely to be unhappy. And that's because having resources means you can keep yourself healthy. It's not just about having a car. It's not just about having a nice modern, transportation system. It's not just about having a nice university. It's also about being healthy. Okay? So again, you can be happier, and if you stare at that when you're at home, you might find some interesting facts about your own country, but it seems to be a robust fact. This is an update of what we did 6 years ago. This is the case of health. If you don't have the resources, you can't be healthy. Okay? This is a fact as well. So let's talk about Big Bob and the model. So I only have like a half an hour. I tend to be dramatic sometimes, but this is really exciting stuff, and it's easy, If you get your head around this, then you kind of get the idea behind the rest of what we're going to do for the rest of the semester. Okay? Yeah. Yeah, it's a great question. So they put a team of international psychologists on this because it's clear that if you ask a person in China what happy means and what a person in Germany thinks with happy, they may be different, And you really have to control for not just being wealthy, because some people may use the word happiness to mean wealthy. So that would be kind of circular reasoning. But in fact, they've really worked hard on this to standardize this idea. And it's a standardized scale, so that's what we're talking about. And again, it's arbitrary. I've seen the questions, and they're pretty interesting. So if you're interested in that, it's Glücksforschung. It's a big deal in economics still, but we've moved beyond just criticizing GDP. Now we want to understand why. What is the component? Is it health? Is it longevity? Is it peace and tranquility? A lot of it is civil war. Who can be happy if you're being invaded by another country? So it's these are things we have to control for. Anybody else on that? So let's talk about Big Bob. Okay, there he is. This is the workhorse. I mean, this is the most cited paper in our field, the 56 QJE paper. He actually wrote 2 papers. One is in 57. It's an empirical implementation of these ideas, and 56 is the one we're going to talk about. It's still being taught today everywhere. So it's kind of a way of conveying some interesting ideas, some concepts, some techniques at the same time. He got the Nobel Prize alone for this. No question, it was an important contribution. And this model has been used to generate more insights about human capital, about other types of capital, infrastructural capital. I've written a paper where we actually look at pollution and mitigation activities, because it's if you can't grow because you're hitting the CO2 limit, then how do you overcome that? You have to remove the CO2. You have to expend resources to remove the CO2. So again, you can use this. This model is incredibly flexible. Okay, so maybe some of you may go into it in your master's thesis. So the unfortunate thing about science is sometimes people get full credit and they should only get partial credit. Okay, so there's an Australian. Australia is very far away. So I've been there a couple of times. It's really, you're way the hell out there. And back then, communication was much more difficult. It was very expensive to get on the phone. And Trevor Swan published a paper in the same year in the Economic Record, I think it was, doing basically a very similar, if not exactly the same thing. And Bob got so I'm going to often call this the Solow-Swan model, because I feel sorry for Trevor Swan, right? So we need some building blocks. So I'm going to get technical with you. We need a production function. We need to start with some relationship that explains where the value added comes from. The value added comes from labor and capital. In Berlin, there's a demonstration every 2 weeks, so not surprising. There's a lot to demonstrate about. So, production function, capital K. You know what that is? This building, these machines, the cars that are being driven outside, the production facilities, okay? Capital. It's different from the labor. If you don't have labor, you're not going to get any output either. So it's a combination of those two things. Economists need the abstraction, so we think of a function that takes the arguments, capital and labor, and gives us an output. It's a technical relationship. It has nothing to do with the market or activity of entrepreneurs. It's just a technical possibility. And at this level of abstraction, we're talking about all the things you need, right? So people who deal with this at the micro level have much more detailed production functions, many different inputs. This is a very abstract starting point. Capital, labor, and then we have this other thing, which is the position of the production function. So if you think about the production function as being a function, it can have a locational parameter. And that would say, well, if I have the same amount of labor and capital and I can produce more output, why is that? The production function has changed. Maybe we have a new invention. We figured out how to use a different type of combustion engine, or we have a different, we developed a new vaccine that's more productive. Okay, so all these things can raise the level of the production function. We call that technical progress. And here we're going to make a very specific assumption. It's the Harrod neutral technical progress. I'll go into detail maybe later in the course. And it's exogenous. I'm not going to try to explain technical progress. We need technical progress to get richer, but given the technical progress, how much can labor and capital do with it? That's kind of the ultimate question we're answering today. Constant returns to scale. If you double capital, double labor, same production function, you double output. This is why Luxembourg and Switzerland per capita are as wealthy as Sweden and the United States. Okay? It's a fact that scale doesn't matter so much. Hong Kong is a huge success story. Singapore, right? How can that be? Well, if you have the right people and the right capital, these are very capital-intensive places, you can do it. And there aren't that many people living in Singapore, right? So there's a chance that this thing might actually work. I neglected to say that we have positive but decreasing marginal productivity of both factors. So putting more labor into the production process yields more output, but if you keep putting more and more labor, the marginal return declines. The same thing is true for capital. More and more capital is good, but at diminishing additional increments. So we call this the neoclassical production function. Very basic stuff. You've seen it. Okay? If you can make the assumption of constant returns to scale, you can divide by the labor input, and the labor input is not just L, it's A times L. It's labor multiplied by its technical power. A is a measure of technical progress, so AL is like effective labor. So if you divide the whole thing by AL, you end up getting a function of one variable, which is just K divided by AL. It's what we call the intensive form of the production function. So it's going to look like you can display it in a two-dimensional graph. You don't need 3 dimensions. It looks like this. Okay? So this is the backbone of the Solow argument. So I'm going to use small k to denote per capita capital in intensive form, in effective labor units. Okay, so you can see what's going on here, that A is growing on its own. A could be constant, but given A, dividing by AL means I'm expressing the capital intensity of this economy, and I'm expressing the foundation of economic growth in this model. Okay, so capital is a source of wealth in the Solow model. That's an exam question. What is the ultimate source of well-being in the Solow vanilla growth model? It's capital per capita. So you can have lots of capital, but if you have lots of people, too many people, it's going to dilute the average effectiveness of the capital stock. That's just the way it is. So one way of thinking about China has had an amazing run the past 30 years. I told you already, 10% per year. They doubled every 7 years for for several decades. And they're really coming very close to Portugal now. Portugal! Hello! Give them another decade and they'll be right in the middle of Western Europe. Okay, that's the way economic growth works. But China has 1.4 billion people. So growing like bonkers does not help if your people are growing a lot. Now, China is not growing so much in terms of people anymore, so this is a good reason to think about population growth as well. And that's what's going to come out of this model. Okay, so a little bit of mathematics. Those of you who are mathematically inclined, you can write down the mathematical specification. We have a continuous differentiable function. The partial derivatives are an expression of the marginal productivity. That's the genius of Alfred Marshall, this idea of using math to really get to the point. The first derivatives are the slope of the function at the point. So it's the first derivatives are measuring the gradient. If I put in more capital, I get more output. First partial derivative. The second partial derivatives are negative, meaning diminishing returns at the margin. And the cross product has to be positive because we assume constant returns to scale. So if I increase capital, that increases the marginal product of labor. So if I want to make workers more productive, I give them more machines. If I want to make capital more productive, I have to give it more workers. And the latter is what we see in Germany now. We don't have any workers in Germany. There's a shortage of workers in Germany. People are demonstrating. They're not working, right? Because they don't want to work. For good reasons maybe, but they're not working. Because we have one ads that say we need people to work in our restaurants, but no one wants to work. Okay. So we have concavity is the implication of all these things in math. It means the curve looks like this. It doesn't look like this. It's concave. That's what it looks like if you graph it. And therefore, we can magically express the slope of a ray that goes through any point as the capital coefficient, the capital productivity inverted. Okay, so the slope of that ray that hits the green dot is nothing but the output per unit of capital. Because I've divided basically output per efficiency unit of capital of labor divided by capital per efficiency unit of labor. The labor cancels out. So that's an interesting idea. The slope of the ray is the average productivity of capital, and the marginal is the slope of the curve. That's the marginal. So what do we see? If we compare these two, which one is higher? The marginal product of capital or the average product of capital?
The average.
The average is higher because before that, capital was more productive because the marginal product is falling. Okay, so now very important fact. At the margin, capital is less productive than its average productivity in this picture. Wow, that's great music. I'd love to go out and party right now, man. It's just so how do we get economic growth in this model? You have to accumulate. You have to accumulate capital. You have to build it. You have to build the university, build a new car, build a building, a factory, Tesla, right? That's going to provide the means to accomplishing the wealth. More generally, it's about growth in inputs. So to grow like China, you need either growing K, growing L, or growing A. Those three components are on the exam. That's the exam question, sources of wealth. And the sources of wealth per capita have to be capital and technology because per capita. Okay? So keep that in mind. Three sources of inputs. It's such a simple model. It's almost like common sense. But it's so important that I'm teaching you in the very first lecture. Okay? So we've got growth all over the place. We've got growth in A, but that's exogenous, little a. We've got growth in L, which is labor, and I'm assuming that people work the same number of hours. You can shrink the number of hours you work per person, but you can't do that forever, otherwise it kind of blows your mind. We can talk about that later. That's an interesting idea, but we're not going to do it today. L grows at rate N, population growth rate. So population growth rate, technology growth rate, both exogenous, and then capital is growing because we save. The way we get our capital stock to grow is we have to defer consumption. We have to not eat the stuff we're producing. In a closed economy, we have no choice. So that's really the insight of the Solow model, is that there's a choice every society faces between do we eat it or do we invest it, save and invest it. In a closed economy, it's clear. The global economy has to be that way. Small open economy, maybe Berlin can live off the frugal Baden-Württemberger for a few decades, but ultimately, if you're a closed economy, you have to eat what you save, what you produce. Okay, so that's kind of basic stuff. So endogenous in this model is very simple. It's capital per capita. And we have to figure out where that comes from because that's basically the horizontal variable in this picture. And it's going to determine GDP per capita in effective labor units. So how do we get there? Well, I already told you we have to save. We have to defer consumption. Okay, so capital accumulation is coming from people's saving behavior over many, many decades. This building was built in 1905. Germans in 1905 deferred consumption. Instead of having a beer, they produced the bricks that made this building. And they both went into GDP in Germany in 1905. I'm serious. In 1905, the Kaiser came here and dedicated this building. The Emperor of Germany. Back then they had an emperor, Wilhelm. I think that was his name. Okay? So to get there, the Germans, you have to save like Weltmeister for many, many decades. That's how you do it. Okay? So the Solow model is establishing causation between the savings rate and the outcome, GDP per capita. That's the causal statement I'm going to make as I appealed to in the earlier part of the lecture. And this means that savings, not consuming, means investment because I can't do anything else with it. The government doesn't exist in this model, or it has a balanced budget. We ignore it. So if I save, it has to go somewhere. It goes into constructing more capital, which means that later I can produce more for everybody. But at some point, that must have an end, because we know that the marginal product of capital is declining. So there's no sense in saving and saving and saving for the sake of saving, because I want to eat it at some point. Great point. It's all about savings, but not too much. Okay, so that's the bottom line of today's lecture. And before the music stops, I have like 15 minutes. I'm going to do this. Okay. Solow said, I'm going to go inductively on this. I'm not going to derive the microeconomic foundations of savings behavior. I'm just going to say Germans save 20% of their income every period. Sounds like most of us. Actually, it's 25% in Germany, maybe even 30%. In the United States, it's more like 15%. So it can vary, but these numbers are extremely stable. They're very stable. So Solow in 1956 said, let's just assume it's constant. So that was an inductive shortcut to get to this great model. So you just need to know what S is. And maybe S can change. Maybe Germans get older and want to save more, or maybe young people don't want to save anymore. Maybe they want to save more. That can change the underlying parameter, which is assumed exogenous in this point. So the savings function is just S times F. S times F, which is S times Y, the savings rate times the level of output per capita. This gives us a savings function. We can plot it on the same diagram we had before. So we're kind of in really good shape. The savings rate will basically be compared with the amount of savings I need to keep the capital per capita from changing anymore. So this is going to be kind of like an equilibrium condition in our model. So I can keep on savings, but at some point I will stop saving when my savings is just enough to cover the right-hand side of that equation, which is how much do I need to keep the capital stock per capita from changing. Because you can see, if you look at the formula, big K divided by big A times L, it's changing for three reasons. One is that big K is changing, one is A is changing, and one is L is changing. And A and L are changing at rates A and little n, no matter what I do. So the economy has to save enough to give all the new people that show up capital, and they also have to keep up with technical progress, because that's making the workers more effective. So there are two things that the savings have to cover. And we can actually show that in a picture. So I'm going to show that now, and then we'll be done. You can already see that in the steady state, the little y is constant, and then that means it's just growing at rate A plus n, the rate of technical progress plus the rate of population growth. So this means that we really should spend more time later thinking about technical progress. It's one of the hardest things to understand, and actually some of the smartest people in my field are working on this right now. A good example is Duran Ashimoglu, who's originally from Turkey, he's now at MIT, thinking about how incentives push people to innovate in certain directions. It's not just exogenous. But again, Solow takes as exogenous, take it as a datum. Okay, now we're going to have a picture pretty soon. So we're going to think about what Kaldor called a steady state, when little y and little k stop changing. So we're going to use that picture we had before, and we're going to call that the Solow diagram. That's my equilibrium concept. It's really simple. Microeconomists look at that and they say, this is garbage, right? But it's a very cheap way of producing an outcome we call a steady state, when things stop changing, given these very mechanical assumptions we've made. And it does seem to be the case that these things do grow at the same rate. So if you look at a mature economy like Germany or the United Kingdom or the United States, the capital stock is measured by the national income and product statisticians, and GDP in real terms grow at the same rate. Okay? And the ratio is about 3 annual rate, annual GDP to capital stock. But it's higher and lower in certain industries, so it depends on industrial structure. This is my picture. So what have I done? I've taken the production function. I've multiplied it by a savings rate that I take as given from outside, inductively. And if I want little k to stop changing, Sy has to be equal to little k times the 3 things. Growth in technology, A, growth in population, N, and delta. What is delta? Right. So we've learned from experience that if you buy a computer, after about 2 or 3 years, it's not worth very much. You can even try to sell it on eBay. It's not worth much. It's not working very well. It's maybe broken. This happens with all capital goods. That's a very aggressive depreciation rate. This building has an appreciation rate of about 1% per year. But if you don't pay to invest, to keep the capital stock up, after 50 years, there's not much left. And that's what we saw when we came here for the first time. The building had not been kept up, so depreciation is part of the maintenance of the capital stock. So to stay rich, to stay wealthy, you need to keep on saving just to replace the burnt out, worn out, obsolete machines that you're working with. Okay, so that, again, I mentioned Cuba, great example. Most of Cuban capital stock looks like it did in 1958. Okay, it's just worn, the weather, everything just wears it down. And if you don't continue to put more resources in, you're not going to be able to maintain the current state. So to maintain that current state, we need to save at least the depreciation, at least the replenishment or the equipping of the new people who come online, and the fact that we have technical progress. So that's a steep order, right? And that's why this capital widening curve has this slope that's given by delta plus n plus a, or a plus n plus delta. Okay, so they cross when savings per capita is equal to capital needed to maintain constant capital per capita, and that's that green dot. And then I can rise to the production function to see what the level of GDP per capita in effective units is. Okay, so that's the Solow model. That's the steady state of the Solow model. And you can see that all sorts of things can go into your calculus. What could change to make that higher or lower? Obviously, the easiest thing to think of is what would happen if I increase the savings rate, right? Who wants to guess? Something's going to shift. If little s changes, so we move from being American savers to being German savers. Yeah. Anybody? Yeah. The S times F curve change, but Y doesn't change. By construction, we haven't changed the technology. It might also change for some reason, but if it didn't, then only the savings curve changes. And that would be like this one. The curve shifts up. You noticed immediately that we don't have an equilibrium anymore because we're actually saving more than we need to keep little k constant. So the thing starts to change. This space is a measure of the pressure on the capital stock in a positive sense, increasing it. So that means we have to move away from k star. K star is no longer in equilibrium. We'll move to k star prime. Okay, so it's basic stuff. This is called a comparative statics exercise. And the previous slide pointed to other things you can change. You can change the depreciation rate. That would change a different curve. It would change the capital widening line. You could imagine an increase or a decrease in the depreciation rate. You can an increase in the population growth rate. So all these things kind of tell us what is important for standards of living in a country in the steady state. Now the question that will arise next week is that a good indicator of growth? Okay, and that's one of the weaknesses of the Solow model, is it doesn't really do well if you think every country has the same production function. And that's the first weakness. We think that, Egypt has some fundamental problem achieving the same output per capita than Turkey or Germany does. Maybe it has to do with the political environment, maybe it has to do with ethnic problems, governance, rule of law, respect, education, etc. All these things that we don't have in here. We don't have in these production functions. The production function is so abstract. It's too abstract. Okay? This can be used in so many different ways. I just want to inspire you to think about it, and this is a very simple start in what we're doing today, but it can also be used to explain the dynamics. So in other words, how quickly do we approach the new equilibrium? And some famous people have looked at this within a country. So the idea would be within a country, within the prefectures of Japan, little regions should be converging at a rate that's predictable by the same model. Okay? Or in the United States. And it turns out that does work pretty well. The convergence rate is pretty low. It's about 2% per year. And if it's converging at 2% per year, how long does it take to close half the gap? 35 years, right? So some very prominent people in the United States were predicting it would take 35 years for East Germany to close half the gap to West Germany in 1990. It's an interesting point. So economic positive questions we've posed, and we've answered them with a model that relates causes to consequences. But Solow model has weaknesses, criticism. Where are the microeconomic foundations? Why do the Germans save more than Americans? Is there a reason for that? Is it tax law? Are Germans just stingy? Or do they have some forward-looking magic that Americans don't have? I don't know yet. Okay? Now, if I had more than 1 minute, I would tell you more about this, but you can use the Solow model already to answer a normative question. How much should a country save? And I'll just give this to you very quickly. If a social planner took the Solow model and said, I'm going to make Germany as rich as possible in the sense of maximizing consumption per capita, what would I do? Well, it turns out if you look at that picture before, you can already see if that savings, the vertical distance from K star to the intersection, then the residual is consumption per capita. That's what makes us happy, not the savings. I don't like the machine tools. I just like them because they help me get a better meal on the table, or I'm healthier. You understand? It's about consumption. So the question of the golden rule is, what should a social planner do if she wants to make consumption per capita as big as possible? The Solow model tells us that. In fact, you can just look at it and you can see that red bar is exactly consumption per capita in effective terms, and of course we're all effective, so that means per capita, right? So how do I make that as big as possible? Well, I make the savings rate high or low to make that thing as large as possible. So if you stare at it, what do you think? Can you see like an optimality condition there? It's a very simple problem, but it must have to do with the slope of this curve, the capital widening line, and the slope of the production function, which is variable, depending on how. You don't want to save too much capital, because then if you're to the right of that, over here somewhere, look how small consumption is per. You're basically saving to buy machine tools that enable you to produce more machine tools, but you don't get to eat the fruits of the machine tools. So you don't want to do that. So Phelps basically showed us, you set the marginal product of the production function equal to the slope of the capital widening line. that straight line and the slope of this production function, which is variable. It's a simple first order condition. And if it turns out that if you want to take this to a higher level, that the marginal product of capital is kind of related to the interest rate, the real interest rate that you would have in the capital markets. So this is the magic of Phelps' famous paper, where he shows that if you want to maximize that bar, you want to go to the peach-colored one. So if you're starting before, you want to save a bit more, but obviously you could save too much, and then you could basically reduce your savings rate and increase savings consumption per capita for free. It's a free lunch. So countries that overdo it for whatever reasons, whether it's this planned economy or a market economy, and this model says nothing about what it is, it's a model about the economy. And that's what makes it so attractive. So even in a planned economy, you can use this picture. Okay. So I'm finished. Tomorrow we'll talk, or next week we'll talk about the growth rate a little bit, and how you can derive that from the same model. Because, of course, if you're above or below, you're going to be moving towards this new steady state. So those growth rates will be different from the growth rate you'll have in the long run. And to make it all interesting, there's a picture that can help you convince you this can't be the end of the story, because if you look at all countries in the world, it only explains a certain amount of growth and convergence. The OECD countries, the model works quite well. Okay. Here are the key concepts to remember. And the slides will be online immediately if you want to look at them. Please go to section Wednesdays and Fridays, I guess it is. And keep your eye out for the new password. And have a great week. See you.